Example 3 provides us with more proof practice. And of course, you should be very confident about what goes first. It is always the given information. So YZ bisects angle WYX, and angle YWZ is congruent to YX, angle YXZ. And that is given. We're going to make sure we mark those on there. So YWZ is this angle, and YXZ is this angle. Those are congruent. And the fact that YZ bisects angle WXY means that this angle and this angle are congruent. So we will now state that WYZ, angle WYZ, is congruent to angle XYZ. And that is going to be the definition of angle bisector. We also see that YZ is going to be congruent to YZ. And need a thinner pen. That is the reflexive property. And so now I can see that my triangles are congruent based on angle, angle, side congruency. So triangle WYZ is congruent to triangle XYZ, and that is by angle, angle, side congruency theorem. Let's try another. We are, of course, given that angle ABC is congruent to angle CED. I'm going to mark that on here. ABC is congruent to CED. I'm going to mark that as part of my given. And then I'm going to say that AB is parallel to CE. So AB is parallel to CE. And one last thing, that C is the midpoint of AD. And I want to leave plenty of room in my box here, so I'm going to leave that all on one line here. And that is given. Looking at our parallel lines, I'm going to extend them a little bit. We've got these parallel lines being cut by this transversal. What else can we determine? Let's go ahead and extend these a little bit further and ask ourselves, is there another transversal? I see this transversal right here. And as I'm looking at those, I can see that this angle and this angle will be congruent. I'm going to go ahead and switch colors. Let's look at This transversal will look at this angle and this angle being congruent. Re-extend this out here. And how are those related? And those are corresponding angles. So I'm going to be able to say the angle BAC is congruent to angle ECD. And my reason is corresponding angles theorem. Going back to the idea that C was a midpoint, that also tells me that AC was congruent to CD. And the reason that we know that is the definition of a midpoint. And now I have enough information to prove that my triangles are congruent. So I can say that triangle ABC is congruent to triangle CED, and that is because of angle, angle, side. Congruency theorem. Go ahead and pause your video and do the try it at the top of the next page. Come back to check your answers. While your video was paused, you should have been able to at least fill out the given information and mark it on your diagram. So LG was parallel to JM, and H is the midpoint of LM. Because H is the midpoint of LM, I should be able to determine that those are congruent. Sorry. LH is congruent to HM, and that is definition of a midpoint. These two angles are congruent, so I can say angle JHM is congruent to angle GHL because those are vertical angles. And then I'm going to need to use the idea that these are parallel lines. We're going to use that these two are parallel lines being cut by this transversal to identify that this angle and this angle are congruent. So angle written over my letters. This is LGH is congruent to angle MJH because those are alternate interior angles theorem. And finally, we can say that triangle LGH is congruent to triangle MJH, and that is by angle, angle, side. Angle, angle, side, congruency theorem.